Okay, well, welcome everyone to the CLF Embodied Carbon 101 presentation. Um, Most of you know me. I'm Tony Giroux, president of the BCABD. We're privileged to have with us two representatives from ZEIC as well as CLF. This morning we have our presenter, which is Stephanie Dallow, as well as her associate, Kim McClymont. So Stephanie is a licensed professional engineer in British Columbia and Ontario, and is the program manager of the Carbon Leadership Forum in British Columbia, which is what CLF is. A program powered by the Zero Emission Innovation Center, which is what we refer to as ZEIC. Starting her professional journey as a structural engineer specializing in bridge rehabilitation, her passion for sustainability led her to the UBC Master of Engineering Leadership Urban Systems program. After obtaining her master's degree, she began working on mixed-use, multifamily residential, commercial, institutional, and office buildings, guiding project owners in identifying their sustainability strategy and coordinating and facilitating communication between design teams to keep projects on track toward meeting their sustainability goals. This included conducting whole building life cycle assessments to determine a project's embodied carbon impact and proposing low carbon design solutions. Recognizing the intersection between waste, carbon, and affordability, Stephanie advocates for implementing circular economy strategies in the built environment as a holistic strategy for reducing both embodied carbon and construction and demolition waste and supporting social equity. We also have Kim. Kim is the program manager for ZEIC and also the program manager for the Near Zero program. So Stephanie will be presenting this morning, but both Stephanie and Kim will be available to answer questions at the end. I am going to open up the chat room once the presentation starts. And if you feel free to just enter any questions or comments into the chat, and then we'll take some time as we have at the end to answer those questions, and we can unmute at that time for some of the members to ask the questions audibly as well. So we'll look forward to our presentation. I'm sure that you'll enjoy it, and I will now turn the meeting over to Stephanie.
Thank you, Tony. And thank you, everybody who made time to attend this webinar today. Maybe some of you have been hearing this word embodied carbon floating around. Maybe some of you are more familiar with it than others, but really the intention behind this Embodied Carbon 101 session is to help you get a better understanding of what embodied carbon is, why it plays this significant role in building decarbonization, and to also introduce you to CLF BC so that you can see and actually take advantage of us as a resource that is available to you, because we want to help support you in designing sustainable buildings and decarbonizing. All right, so let me see if this is working here. There we go. So then just a little bit more of understanding too about CLFBC and Zero Emissions Innovation Center. So CLFBC is a part of this family of programs, which is nested within ZEIC. And Zero Emissions Innovation Center is also the BC contingent for the Low Carbon Cities Network. So we have funding to run several programs, and they're all part of the building decarbonization goals. Some focused in B2E, for example, is focused in facilitating and supporting building electrification. There's a BC Retrofit Accelerator, which is offering on-the-ground support to making energy retrofits happen. And then Near Zero 2, which is the program that Kim is managing, is all about supporting building research. And then ZEBEX is one that often is like very familiar to people. It's the Zero Emissions Building Exchange. And it is a part of it is kind of understood to be the main convener and amplifier for the whole team. So it's, if you're interested in zero emissions buildings, then that's like a good point of contact. And then you have but once you kind of speak to the program manager, Natalie, she can also kind of connect you with one of the right programs that, suits what you're trying to achieve there in your goals, in your project. And so CLF is focused specifically on eliminating and reducing embodied carbon, which is the carbon embedded in the materials and in the construction of buildings. So CLF is a center of excellence for embodied carbon reduction. And we have more to Zero Emissions Innovation Center. We also have a team that is focused on Sustainable Workforce Coalition. So there's more beyond buildings. And I wanted to share this. We just celebrated 5 years of CLF BC just last month in October. And so we've seen a lot of growth in industry and capacity and understanding of embodied carbon, and how to track it, measure it as well as reduce it. And there's been some really nice wins in terms of just helping to work with local governments in developing policy. And so I'll get to more of that later. But really, I just hope, show it's such a great community. And if you're interested in getting more involved, you'd meet some really amazing people. And so I want to take this moment just to thank Tony, to thank BCABD to put this presentation or to organize this one-on-one, because, carbon is such a just like one piece of the bigger sustainability goals that we have, and building structures or building cities that are thriving, as well as sustaining. And so understanding the carbon piece and the embodied carbon piece is really important. And I'm grateful to have the opportunity to chat with you all. So understanding that your goals as members of BCABD is to raise the standards for building design. We're hoping to do that through building decarbonization. And so by meeting you all and building our network also and connecting with you, we're hoping to kind of get to this goal together with you. And so embodied carbon, the session is to we'll also talk about, so this is just kind of this slide is to kind of run you through today's. I'll give you an embodied carbon life cycle, an introduction to embodied carbon and life cycle assessment, kind of give you an understanding of what it is and why it matters. And then I'll cover some tools and strategies for reducing embodied carbon. And then I'll introduce you to the Near Zero 2 program, which is the applied research project for Part 9 buildings. Okay, so getting into it then, some people might know this, some people might not, but cities are the largest place-based source of greenhouse gas emissions. And so although the production of carbon emissions is a global phenomenon, cities are responsible for 2/3 of global carbon emissions. And even though cities take up 2% of the Earth's land mass, they are responsible for 80% of the energy use. And this is going to increase the more people move into cities over the century. And so there needs to be this effort as we try to meet demand for housing, for other types of building structures. We need to really get an understanding and a handle on our carbon emissions so that we could both meet those needs while not continuing to harm the environment, which in turn harms people who even live within the environment. So just also as part of this kind of introduction, I'm sure that you've heard many different names of carbon. There's embodied carbon, which we'll use a lot today, and that's kind of the main ones that we'll talk about. When we report our emissions after conducting a life cycle assessment, we report them in carbon dioxide equivalents. You might hear carbon footprint, carbon dioxide, greenhouse gas emissions, fossil fuel, global warming potential. This one will be a bit of recurring too, and I'll explain where you'll see GWP more. And you might see climate change potential. So there are a number of these terms, but they don't necessarily share the same meanings. I don't want to give in this 101 too much like bogging you down with all the details, but just to let you understand that you might hear things used interchangeably we focus in when we talk about embodied carbon, we talk about them in terms of carbon dioxide equivalents, and we also refer to global warming potential. And even though the term carbon is associated with climate change, it is not technically it's technically not elemental carbon that is contributing to to climate change, but carbon dioxide gas, along with many other substances like nitrous oxide and methane, those are part of the carbon dioxide or greenhouse gas emissions. So, but nevertheless, carbon is often used and is abbreviated to refer to global warming potential. And again, like talking about the why to just help people understand. Some of you may have also been hearing about the Intergovernmental Panel on Climate Change years ago, just doing a lot of, countries around the world joined together to say that they declared that they're committed to, you know, ensuring that they would put measures in place to ensure that they would not exceed 1.5 degrees or 2 degrees of like increase in temperature, because if by like the sad news is we failed on that. We'll get to that later, but that's kind of the reason for the emergency, and this climate emergency is because by not meeting this goal, we are seeing, and we've been warned by leading climate scientists, that by not hitting that mark, by not ensuring that we keep the maximum of like a 1.5 degrees increase by 2030, if by not doing that, we're going to see this, there will be this risk of more droughts, floods, extreme heat, and poverty for hundreds of millions of people around the world. And it's hard, and knock on wood, if some people really don't feel this, but unfortunately, a lot of people are feeling this in many places in the world. We see it from, recently Valencia in Spain had an unprecedented flood that devastated the country. Similarly, a recent hurricane in the US in Asheville, North Carolina. This is some stuff from 2021 with Abbotsford and the flood in November of 2021. And California had some devastating wildfires that were also unprecedented over 2020 and 2021. So these are in North America, we're seeing these impacts and the way people are feeling it. I haven't even had the opportunity yet to go to Jasper, but this is a video showing the aftermath of the forest fire that devastated Jasper, and people who are so connected to that land and to the environment and to that beautiful scenery are now really, really having to kind of grapple with this. So this is just to show you that like it's real, and we see a lot of youth really pushing and trying to, demand climate action. So this is really something that is driving the why. Why are we doing this? How does talking about this big idea of climate change actually come down into something tangible of what we as designers, engineers, builders, owners of buildings, like what can we be thinking about in the way we do our work so that we can demonstrate to these kids, this is what we're trying to do to mitigate and to offset this risk. And I think this is a good time, maybe, I know sometimes it's like very top of a presentation to give a land acknowledgement, but I kind of wanted to do that first to just, acknowledge that after all of that to say, we are on the unceded and ancestral territories of the Musqueam, Squamish, and Tsleil-Waututh Nation, and they've been a steward of the land since time immemorial. And this picture on the, whoops, sorry there. The picture on the left hand is on the unceded ancestral lands of the Musqueam. That's the Pacific Spirit Park near UBC's campus. I love to go there a lot with my dog, but just kind of the contrast and seeing like a forest, a natural environment left in its natural state, versus a city that's developed. There's so much that we can be proud of when we think of as designers, as people in the engineering, architecture, and construction industry, but just understanding that cause and effect of the work we do over time, understanding it better, the externalities, and learning from that to how do we now kind of iterate the way we do our work so that we are not harming the environment, but actually enabling it to thrive. Uh, and so embodied carbon is directly linked to public health and equity. The IPCC, which I referred to earlier, talks about a just transition. That's very like American, there's the buy clean policy and everything, but this concept is really about a set of principles, processes, and practices that are aimed to ensure that no people, workers, places, sectors, countries, or regions are left behind in a transition from a high carbon to a low carbon economy. And so there's, understanding that embodied carbon, where our goal is to mitigate global climate change, to reduce regional and local health impacts, and to increase supply chain transparency. Okay, so that's the why, right? So now I'm going to get into what embodied carbon is, and then next we'll get into how we reduce that. There's a little bit of how we measure it here, and then we'll get into some strategies. So the term embodied carbon refers to the carbon emissions associated with an entire life cycle of a product. And it typically includes emissions from energy use, known as operational carbon. But it's most frequently applied to construction, where the product is new or renovated buildings. In Vancouver, the embodied carbon of construction is closely associated with what is referred to as Scope 3 emissions, or consumption-based emissions of the construction sector. My next slide, just to kind of now, and I'll kind of break down a little bit better the difference between just a life cycle assessment and a whole building life cycle assessment. So a whole building LCA is a term that is referred to the life cycle assessment of an entire building. That includes various stages, which captures the product stage, which is raw material supply, transport to a factory, and manufacturing of the product. Then the transportation of that material to the job site, and the construction, the emissions related to the construction of that using those materials. And then there's the use stage. And so I know we talked about operational, but in the context of embodied carbon, during the operational period or the use stage of this of the building, any emissions that any carbon that is emitted due to any maintenance or repair or refurbishments or renovations or retrofits, of your building during that use stage, those are referred to, that's the carbon, embodied carbon during that phase. And then there's the end of life. There's the emissions that are a result of the deconstruction or demolition, commonly demolition at this stage, but we'll talk about strategies later and where deconstruction kind of comes into the picture. And then, of course, the transportation of that material to the landfill or wherever it's being processed, and then any emissions related to waste processing and disposal. There's also one more stage beyond this, but in a whole building LCA, when depending on what's driving the LCA, what framework, if you're following City of Vancouver policy, or if you're following frameworks like the LEED certification, or there's a Canadian Green Building Zero Carbon certification, they have different they require you to measure and include these stages from what is referred to as cradle to grave. So that's the product stage, construction, use, and end of life. But there's also beyond building life, which if you do track that would be reported separately. But that's anything that is usually a net positive to you, that to your project, if you are reusing materials, if you're designing them in a way so that beyond the building life, they can be captured and reused, that can help reduce your overall whole building life cycle assessment. And by the way, like I know this is like we'll have time for questions in between each, kind of before I get into the how and then the near zero, just so if you're kind of coming up with questions as you go, you don't have to wait too much till the end if we can kind of have a moment in between. Um, Okay, so also typically when we talk about the embodied carbon of a building, we are talking about the substructure and the superstructure, the building envelope. And this is referred to as the structure and envelope scope. So it is most often used for the LCA, the life cycle assessment, LCA submissions. And so, but that really limits us in terms of, the precision or the accuracy of like our whole building's embodied carbon emissions over its life cycle, over its lifetime. And so, it's not giving the full picture because it's missing a lot of the full scope emission pieces of interior partitions, mechanical equipment, lighting or landscaping, interior finishes. So, as we continue to build capacity and learn and understand these gaps, this is not just like we are probably missing a big opportunity of other areas to intervene and reduce emissions. And so, as we continue to grow and understand embodied carbon, we want to be understanding these elements as part of the full scope emissions better. We want to start tracking them and finding ways to reduce those emissions as well. And then this is just like a little bit of a fun exercise or just to kind of get you quantifying embodied carbon a little bit better. So there are a few scenarios here. One of them, in that top left, is a flight from New York to London, or the concrete truck there, that is 1 cubic meter of concrete in the Canadian industry average of a 35 MPa mix. Then there's if the other scenario is, what if you were to cut out meat, dairy, or beer for 1 year? What would those emissions be? And then in this bottom right corner, that is a library, and just thinking about what would the carbon emissions be for just all of the concrete beams in that structure. And so when you compare them, they're all, it's all relative and they're all significant in their own ways, but you can see that that the transfer beams just in one library is 600 and over 640,000 kilograms of carbon. The CO2e, that's the carbon dioxide equivalents. And so, from a personal perspective, you might say, oh, I could be a vegetarian for like just cutting out that for a year. If 320 people decided to cut out meat, dairy, and beer for a year, that's the same as just the emissions for the transfer beams in a library. So it's very high impact of, if we start to really look at the building industry, we can make a lot of significant reductions, and it could really help us meet our climate goals. And so building on the why and helping to understand this piece of the whole kind of global greenhouse gas emission breakdown, building operations, when you think about operational carbon, which there has been a lot of focus on over the years, it is 18% of the greenhouse gas emissions. This is a study of 2019. Whereas building materials and infrastructure, the embodied emissions related to those is 17%. If you just think about building materials, wait, sorry, before I go there, I just kind of show this this graph as well, that over in the total carbon emissions from 2020 to 2050 over time, if the business as usual projection happens with what the operational carbon emissions are projected to be compared to embodied carbon over that period of those 30 years, then we'll see that they're very similar, that embodied carbon takes a lot of that chunk. And so we need to start understanding this better There's this misconception even, and it's not necessarily a misconception. I would say it's just a little bit of a behavior or mindset shift. Is as we did a lot to learn about operational carbon, it helped us to now see like, oh, embodied carbon is something meaningful. We need to understand this better. And people, I get it, kind of struggling to, I'm just understanding operational now. You want me to understand embodied and seeing it as like, which one do I prioritize? There's work to be done in helping this shift in mindset because they're not in competition with each other. It's really about understanding both of these things to know where you can intervene in your design to reduce as much as you can because they're very interrelated. A decision to reduce embodied carbon might end up having impacts on operational carbon and vice versa. But you can find, if you think of it more as a performance-based way of reducing your emissions and you have a target, thinking of these things together is important and not, it's one versus the other that I need to consider. Another graphic I like to show here is when you just even think about the building this is 2018, and so these numbers are old kind of compared to, I guess, even like this one here, but the same chunk, if I consider 7%, like if I look at the building operations with building materials, that's 25%. And if I think of what the 7% of the 25% is, it works out to be the same as if we looked at like, I don't want to complicate this, so I'm just being mindful of time, but my point is when you look at the full pie, the embodied carbon is currently at this date is 30% of the emissions from building sector. And so it's a big chunk and we do want to understand that better. And when we think about the time value of carbon, something that is so instrumental or such an important part is if we have these goals of reducing emissions by 2030 or by 2050, the emissions that we're from the materials from construction, that is locked in. That is what this, right here, is showing here is that this is locked in, as soon as your building is operational. And so it's important to think about the upfront carbon, reducing those emissions and thinking, how do we make sure that we're doing what we can with now to reduce those emissions? Especially as you see here, if the scenario 2 is that, we are designing higher performance buildings over the lifetime of that building, the impact is coming from the operational carbon. And this is just another study. This is from a great study from 2023 that just came out from RMI Group. Again, just kind of confirming that the upfront carbon, the majority of a building's total emissions is released at the upfront, is at that product stage and construction stage. But you can also notice, I just want to show here, that there's a big gap, like there's a big range rather, 35% ranging of like product stage. So where does that mean? In the way that we have been tracking other emissions of A4, A5, B1 to B5, C1 to C4, end of life, there's a lot of opportunity to understand those better, and they probably likely have more impact than we realize. And so just getting to understand that better is important in the way to help us achieve those reduction goals. Quickly, also just to point out that we have the City of Vancouver has these goals of reducing emissions by 40% by 2030. This is a part of the Climate Emergency Action Plan, big move number 5, which is to reduce or to focus on low carbon materials and construction practices. So this is like directly addressing embodied carbon here, which is really great. There's this bill I include here. It's a federal bill, net zero emissions. It's great that these things exist and they signal this need or this desire to be net zero. But what I think are fair criticisms of things like this type of bill is that people will point out that it's not legally blinding, that it lacks a clear plan, or it has no cost estimate, or they'll kind of make these statements. And I do think it's fair to challenge that, but when people say make those criticisms, I think it's fair. But at the same time, I think it's good that these things exist because it is an incentive for other tools that have come up. Again, with time, I haven't showed you, but there are other organizations that create frameworks to help guide design teams to reduce emissions. So there are commitments that people make, like a structural engineering 2050 commitment, where different engineers across organizations are committing to, excuse me, to designing or to reducing the embodied carbon of the structural materials in their projects with this goal of, so that by 2050, it's a net zero buildings. And there's also the AIA 2030 commitment. So a similar commitment, but with architects committing to reducing emissions by 2030. So these are things that are showing that the industry is really serious about this and wanting to do this. And so, acknowledging time right now, I'm going to jump into just tools and strategies. I'll try to keep it quick, even with this. And then when we get into the conversation, we could talk about it more in a more fluid, open discussion type of way. I will pause, maybe like if anybody has a burning question before I move forward, I'm happy to see if there's anything in the chat, whether Tony, if you want to just let me know if I'm not seeing the chat right now, but if anybody has a question, I'm happy to answer it before moving on.
Sure. Yeah. No questions yet. I think you're rolling along good. If there is a little at the bottom, I think there's a choice. It might be hard for you to see because you're presenting, but just would say chat. It's right beside
Oh,
participants, and it should bring up that on the side for you.
I see it now. Yeah, yeah.
Yeah.
Oh, I see that there. Okay, great. If I notice anything, sure. Okay, great. So for reductions, like tools and strategies to reduce embodied carbon, this has been something that's been in development. In fact, some of these things are what engineers, what designers, what builders often are doing to optimize the design, to design more efficiently. And when we are tracking the emissions, when we're measuring the baseline design and then finding interventions, we'll see that that a lot of this is not new to us. Many people are doing these things, and now it's about measuring it and showing that we can reduce these emissions and trying to kind of raise the bar so that this could be like a new industry standard. Maybe I'm getting ahead of myself when I say that, and when we get into the kind of a little discussion about policies, that'll be maybe more relevant there, but. So some just high level types of ways of thinking and to reduce embodied carbon. Very simple in a way. It sort of reduces it to these very simple ways of thinking of build less, reuse more, design lighter and smarter, use low carbon alternatives, and procure lower carbon products. So very, very kind of bullet point ways of thinking, but very I think is still strong, and like those are very important strategies that can really meaningfully help you achieve reductions. There is this similar report that I was talking about earlier from RMI. They had these top design interventions for embodied carbon reduction, and kind of like similarly kind of like reiterate these strategies. And so reuse is one of them, reusing an entire building or components of a deconstructed building and limiting the scope of renovations to what's needed. Prioritizing salvaged materials over new products, that's one. There's also right sizing, optimizing building sizes and spaces. Dematerializing your buildings or carbon storing materials. So exposing that structure instead of applying finishes is a way to dematerialize it. Carbon storing, building projects can ask for responsibly produced bio-based and concrete materials that are storing carbon. Then you have product substitution. So when you are tracking your LCA and you start to see, oh, these are like intensive materials in terms of carbon, that's where you get to then make a decision of what can we swap out here. Sourcing. We just had a wonderful, it will be on our CLF website probably in the next few weeks, but we had a decarb lunch through ZEIC. It's a kind of a podcast. We invite people in industry to speak, and they talked a lot about how sourcing, depending on where you're getting this material from, it might have a bigger impact on your emissions goals than you realize. So knowing where you're sourcing your materials from, understanding this at early stages of design can really meaningfully like be a make it or break it for you in terms of like reaching those carbon reduction goals. And then circular design is, I would say, a very, to me, I think Tony, in my introduction, I advocate strongly for circularity. People don't maybe necessarily fully sometimes see that relationship yet between reduction or decarbonization and circularity, but really this means to reduce the impact of a building's life cycle and enable low embodied carbon future construction by prioritizing reusability and recyclability. So that would mean designing your building to be disassembled or adapted for reuse in the future. And just in this nice triage, I like to show some people. This is one I use often because it's just the perfect capturing again of that like build nothing, build less. But really, a lot of what we're talking about here is in the like build clever, even of like using low carbon materials and products and reusing or designing for disassembly. But yes, all of these strategies are important and can have high impact, but the less material you use as new is kind of going back to that upfront carbon piece. If you are preventing the need for new concrete and steel or even new wood materials as well, even though they're bio-based, it depends on if they're sustainably forested. Like you can really reduce emissions by retaining your existing structure. So another tool I want to introduce you to, we have developed within CLF BC a low carbon material sourcing guide. Maybe Kim, if you can drop the link into the chat for people just so they can go to it. Sorry, I don't have it ready for me to drop in. But this is a tool for builders and designers to show the lowest carbon products that are available in BC. We had Reload Sustainable Design. They had put this together, but they're continuing to manage it with some amazing CLF volunteers that are continuing to make sure that we have materials that include, I didn't explain it enough, but the one way to make sure that you have the information you need on your materials to know if you're sourcing low carbon materials is to choose materials that have what are called environmental product declarations or EPDs. And I apologize, I don't have a slide to show that. It would have probably been a boring slide, honestly. But really, environmental product declarations, they are required to report on the global warming potential of the materials from that product stage, the A1 to A3, which is the raw material extraction, transportation to the manufacturing, and then manufacturing emissions. So when some products, the ideal is to have very product specific EPDs. And so this low carbon material sourcing guide for materials that would be used in Part 9 buildings. Arguably, some of them could also be used in larger Part 3 buildings, definitely, but really the goal was to be for the smaller residential, the sourcing guide. But we included materials in BC that have product specific EPDs, or there's also just like industry average EPDs. So often that's what's done with like industry average for concrete or steel. So we have that information in the sourcing guide. We're continuing to build it up. If there are new materials that come up that have these information EPDs available. But yes, our team of volunteers that are maintaining this sourcing guide are contacting manufacturing facilities or suppliers to make sure that this is staying up to date with all the information. And that information also includes their contact information of those suppliers and manufacturers. So this is a really, really amazing tool for you guys to reduce emissions. And so there's more to come with the way we'll promote this so that more people understand it, and we'll have better, if people are interested in learning more, we might even have like 101s just or just like sessions just about the sourcing guide to make sure people are using it to its fullest. And so, yeah, really the goal is to minimize materials, design smarter structures, and to offer low carbon alternatives to builders and designers. And then that just takes me into the Near Zero 2. So this applied research project for Part 9 buildings, it was inspired by, this need to start understanding, and benchmarking in Part 9 buildings, because a lot of the work has been done in Part 3. And now we're seeing policy and benchmarking has been done now in that space to now allow City of Vancouver to approach, I'm kind of jumping, my slides are maybe not in the best order, so I'm just going to jump ahead here. But the City of Vancouver is proposing changes to the Vancouver Building Bylaw for the 2025 updates. And I won't bore you also with these details, you can look later, but it, the intention is to do something similar over time for Part 9 buildings. And so, Builders for Climate Action, Melanie Trottier is on the call today, and she helps us with the Near Zero 2 stream. There's a BEAM life cycle assessment tool that we use to track emissions, but really the goals of the Near Zero 2 is to identify existing solutions that can be implemented today for little or no cost premiums, to identify materials with high embodied carbon that can be replaced with low carbon equivalents, and understanding the barriers to uptake, catalyzing and inspiring and accelerating the understanding of constructed or understanding of embodied emissions related to construction, and material selection, low carbon material selection, and also understanding where education is still needed for widespread adoption of these low carbon homes. So if you're interested in learning more about the Near Zero 2 stream, we are right now taking, we have a few more spots remaining within the program that we've reserved for larger Part 9 homes, because there's different things we can learn from the larger the homes. So anything of a multiplexes, 4 units or more, you can receive up to $70,000 for as a research honorarium for that work. So Near Zero 2, Kim is the person to be in touch with, although I'm also a part of that and supporting, but she is the program manager. So if you have questions, you can reach out to her and see if your project would be eligible, and maybe this would be an awesome way to get you to get involved with ZEIC and CLF BC. And so one thing we can get into the Q&A now, but just to highlight just some takeaways are some strategies that came out that we've recognized even in this Near Zero 2 program so far, is that choosing low carbon concrete mix, or using cellulose insulation wherever possible, or even choosing low carbon embodied carbon would really help to reduce your emissions. And same with if you're able to use salvaged materials into your new building. Although there are some barriers to getting that going, like just enabling deconstruction and storage of materials. But once that is enabled, this reuse can open, deconstruction can open a flow of also low carbon materials that could be reused in interior finishes as flooring or walls. But these circular principles, you'd like to upcycle a material into its original function. So if something was used as a structural element, ideally you would want to reuse it as a structural element. There are some barriers with that, especially with wood, but there's still a great opportunity to use wood out of existing buildings that would otherwise be demolished, and using that wood for other, like I was saying, flooring or walls, and that could help you achieve some really great reduction as well. So I will leave it at that. We have about 15 minutes left, and maybe we can just open it up and have some Q&A. I hope that you enjoyed that.
That's great, Stephanie. Thank you very much. Very informative. I'll wait to see if anyone wants to raise their hand. We can unmute you for comments or questions, or if you want to put them in the chat. I would have just a question for you for our group. So what would be 2 of the top products to avoid in wanting to reduce carbon? or to achieve the embodied carbon incentive? And what would be two products that you would want to try to use more of?
Mm-hmm. No, thanks. That's a good question. And maybe even Melanie, if you want to jump in at some point. It's interesting because sometimes and I come from like a structural background, and on one hand it's like you want to be material agnostic and choose materials that you know, concrete performs best in certain applications, steel performs better in certain applications, timber can perform better in certain applications. So, sort of dispelling this like one is better than the other, but certain principles to consider of where are you sourcing materials from? If you originally were thinking I should use mass timber instead of concrete because concrete is high intense, the cement in concrete is the carbon intense part. Some people might say, okay, well, I know I need to use concrete, but maybe I will see where I could use low carbon concrete instead of the typical, where we use supplementary cementitious materials. That's a very good low hanging fruit if you were to find a solution to reduce the emissions of that kind of strategy or of that kind of material. Sometimes what happens is people will say, I know that bio-based materials, they are bio-based like mass timber, but they will say, oh, this is going to perform better because it's a renewable material compared to concrete. And they might then, in some ways, theoretically, yes, that might seem like the obvious thing. But depending on where you're sourcing that mass timber from, if it's coming from a distance that's very far, those emissions in transportation might end up being worse than if you just procured concrete locally, and tried your best to reduce emissions within it in that kind of way by choosing low carbon. So that's just like one example. So thinking about where you're sourcing materials from, how local it is, thinking about reductions in that way. So yes, steel, for example, could be a very high intense material. And I wish we had the link to show. Kim, if you could also do me a favor and drop in the chat. Actually, I'll share my screen again real quickly as you do it, because we have so many great resources on our website. And so the presentation that was just done yesterday talks about these emissions and talks about steel. Are you seeing the right screen? Like my slides?
I guess, Melanie, I'm going to make you co-host so you can unmute yourself here.
Oh yeah. But yeah, so I was just going to say, it's steel or concrete, like depending on where you're sourcing from also and their grid, that upfront carbon would be high depending on where that material, how intense if it's like a heavy fossil fuel um, yeah, if the grid is using fossil fuel emissions to produce the steel. So those are kind of the thinking behind reducing. So you'd want to use like insulation. XPS is high emitting, but there are low carbon solutions for cladding for insulation. So it's maybe I'll pause there because maybe I'm getting sloppy with answering that because I think it's just not a one size fits all. I think that's what I'm struggling to answer is because sometimes people will think, oh, low carbon concrete, my strategy of reduction will be low carbon concrete on this project. And they'll make that decision early on. And it seems like in theory, yeah, you're going to get your target. And then what happens in the construction phase is they might realize, oh, the cure times, because this is the case with using supplementary cementitious materials that are lower carbon, it impacts your cure times. So then some people then decide, oh, based on our milestone, based on our scheduling, we no longer can use low carbon concrete. So their original goal of like reaching a certain reduction ended up being reduced, and then it was too late in the project to start applying other kind of strategies. So that's why it's good to consider several strategies, and realize that there's not always going to be a one size fits all for your project because of certain like other factors that might be influencing that.
Right. Okay. And I'm thinking too, like, I'm just looking through your list of, do I have any other questions here? No. So I'm just looking through your list of materials and the ratings that they have for um, their carbon emissions.
Mhm.
As an example, I'm looking at cladding,
Mhm.
and I'm seeing that the LP Smart Lap Siding, which is a wood product, is 2.5 times less carbon than a hardy board, the
Mhm.
equivalent in hardy board. So those types of things for designers, if those would be very easy things to adjust, is using the those different products, right? Or if, for example, if concrete here rates very high with carbon emissions, then wood is obviously a better way to go. So if you have the choice between doing a concrete wall or a
Mhm.
wood wall,
Mhm.
the concrete wall might be decorative, but it's those types of choices would be environmentally wise choices. Is that correct?
Yes, yes. And that's why like I'm not that's why I keep referring to the presentation yesterday. It's very different, like depending on like that was a structural engineer presenting on structural elements. So the volumes of concrete, like the sizes of mass timber, is very different. And what he was pointing out, he actually comes his experience is he's from the UK, and a lot of the work done in Europe is where we learned a lot from in embodied carbon, but they're much smaller, like their transportation distances for sourcing materials are very different to North America. And so what he was presenting on was showing that because right now, environmental product declarations that we even use to influence our decision making, that only tells us the A1 to A3, that like the production, the manufacturing, and where there are gaps still in the way we quantify emissions is in the like other stages, including just the transportation now from the manufacturing to your job site. I know this like it's not it sucks because we're not trying to complicate this, but on another hand, it's important to think about because we're realizing that some people might have that notion that, oh yeah, I should just use wood. Wood is better than concrete. Yes, if you're just looking at the A1 to A3, but if you're sourcing it from somewhere that's really, really far to use the wood instead of the concrete, then you might actually end up seeing greater emissions than you and if you're not tracking that properly, you wouldn't even know. You would be thinking you're doing the right thing, but just unaware that you are. So that you're actually maybe causing more emissions because of the sourcing. So there's things to look at. There are consultants that help specifically with this, like Melanie is one of them. Melanie, maybe you'll want to chime in actually at this stage. I see you, yeah, unmuted. Okay.
Yeah. If I just want to add, like, so for part nine buildings is much different than part three, because like part three, the structure is a major factor in embodied carbon emission. But in part nine, what we found with our studies is the low-hanging fruit are concrete, insulation, and cladding. So this is the place that like everyone should start looking at to have the biggest impact. Like reduce the amount of concrete that you need, but also change the concrete mix that you're going to be using. That's like, if you can just look at that for your next project, that would be a big win. The next one is insulation. There's so much option for insulation, and some of them actually can be like storing carbon because as they grow, they are made of plants, and like as plants grow, they capture CO2 from the atmosphere, and that's a goal. We want to remove CO2 in the atmosphere to limit global warming. And they keep that seed, the carbon, within their body. And if you think about annual crops, they're gonna die at the end of the year. So if we don't do anything with them, they're gonna release that C and become like CO2 and back in the atmosphere. So there's a lot more option now of insulation that are bio-based. So we can think of hemp bath, even like compressed straw panel. Those are like great option, a bit edgy. Right now, the like really go-to is cellulose, because cellulose is a waste. So if we don't do anything, like it's recyclable. If you do anything with it, it will release that carbon. So that's a great way. If you can avoid any like spray foam insulation, that makes it really hard to unbuild after, because as soon as you put spray foam on a stud, you cannot separate it. It's like impossible. So avoiding any spray foam for your health, because there's a lot of off-gassing after you apply it when you move in the house. So that's really bad for the occupant's health, but also there's a lot of emission related to spray foam, and then it makes it impossible to unbuild. So one material, to answer your question about which material maybe we should avoid, spray foam would be the top on the list for all of those reasons. And then any other foam base insulation, because they're mostly from fossil fuel, and we know that fossil fuel is a form of carbon that is like in a deep stage. And if we don't touch it, it will stay like that. But if we bring it up, then it like liberates CO2 and then again in the atmosphere. And it takes millions of years to go back as fossil fuel. So any insulation that is foam-based, try to avoid it. Mineral wool, it's natural because it's mineral, right? It's rocks. But the energy needed to bring a rock to a fiber is a lot. So right now, depending what the manufacturer use for energy to bring that mineral wool back or board can also be quite high, but like much better than foam. So there's not a clear answer, but I would say for any of you on the call, like try that are working in part 9. In part 9, we really see like concrete is the first major part of any part 9 building, I would say like the emission is there. So if you can reduce the amount that you use and change the mix, and also look at the insulation, make smart choice for your insulation, and a tool like the beam tool help you to really see easily and compare different options without even having to model a home. You can just go into the tool and then see different options and talk with your client and talk with your team and see like, okay, what do we want to achieve there and which one can we use? And again, like cladding, it was the other one. And exterior cladding, as you mentioned, there's a lot of option there too. And brick is one of the highest. But maybe if you want to use brick, there's a way to use salvage bricks. That's a big thing in Quebec that they do. So yeah, I would say like part 3 is a bit different than part 9, but that's where I would start digging.
Yeah, no, those are good comments. And I think that what I'm thinking of from the standpoint, and there's some questions we'll get to in the I don't know if you can see those, Stephanie, in there. You can figure out how you want to answer those. But what I'm thinking from a building designer standpoint is that when it comes to reducing concrete, sometimes it's as much as just paying a little more attention to the size of footings we're specifying. Sometimes just design, we can get away with, for example, a 16-inch by 8-inch footing in a lot of situations, but builders might prefer to do a 20-inch footing because it's easier to put their forms on. But those reductions over, if a designer is doing 100 to 300 houses a year, that's equivalent to quite a bit of concrete when added up. So just little decisions. Not using rebar when it's not actually specified to use in the code. There's a lot of times where we'll specify rebar that actually is not really required. So just thinking on our own projects, is this really necessary to achieve what we need? Or am I doing something just because this is how I've always done it, right? So Stephanie, did you want to answer any of those questions on the side there?
Yeah, sure. And thanks, Melanie, for getting me out of I was anchored into part 3 thinking. So thanks for bringing us back to part 9. Yes. So I appreciate those answers. So I see a question from Ryan. Wait, I want to make sure I didn't miss any before. Okay, so I think Ryan, you were asking about the calculator tools, the LCA tools you use Athena and Beam, and you were wondering about hearing some thoughts from that. So I definitely I myself have had like experience using different tools as well, and I know they kind of have their pros and cons for different things. Beam right now is actually the tool that was developed by Builders for Climate Action, so Melanie, and I know that like in my like honest way of looking at these, usually where I'm wanting to see like the way they continue to develop is the life cycle stages they capture. So I know that there are certain things like EC3 or others that I think EC3 has been updated though maybe, but I think like Beam right now is just looking at the upfront carbon, right, or the product stage. So when we talk about whole building LCA, that means that Beam right now is not doing the whole building LCA. Because we're trying to make this accessible and learning and understanding this, it's good to not maybe be a perfectionist mindset just at the stage, but understanding that those are ways that we can better understand the full impacts. So that's kind of like my main, I guess, thinking about. I haven't used Athena specifically myself, but I know a lot of people have, and it's a free LCA tool, right? So that's why it's beneficial and accessible, and it's a good tool. I like other tools but like I used to use One-Click LCA a lot, but that's an expensive software. It has really good like visual data, but for the Part 9 space, Beam seems to be the best tool right now for like these types of structures.
And
Um,
I would add, like, it depends what you're looking for. It depends which answer you want to answer. Like Beam may be answering some question at the beginning, maybe you need to switch to Athena after. If depends, like, do you want to be compliant with a program or a policy or anything that like they may guide you and like, oh, actually you need to use Athena for that. Or so it really depends how you use it, what you want to answer, and yeah, what's your budget too. And yeah. So it's not they all have, like you say, advantages and disadvantages.
Yeah, I hope that's somewhat answered, but I'm happy to also like something I want you all to know is to please like reach out to me. I think it's on the last slide, but I'll also drop my email in here. Because like as people want to just learn more and have more of these questions, if you want to talk one-on-one at some point, we can try to connect and I can answer like with more details. But okay, so just being mindful of time, but I know that there are other
Just
questions.
before you, Stephanie, answer the next question, I'm just going to mention, because some may have to log off because the presentation was 9 to 10. We're going to keep going as long as we have questions and people online. But if you do need a certificate for some reason for CPD points, email info@bcabd.org, and the name of the person or people that watched, because I know from some of the logins today, there's multiple people watching. So put in who the certificate or certificates need to be made to, and we'll email you a certificate that you can present to your different body. Either ASTTBC, you'll earn an hour for informal learning under training this morning, and as BC Housing, you can also earn 1 point for today's presentation. So I'll let you carry on again, Stephanie.
Awesome. No, thank you. Okay, so I saw yeah, a comment about difference between part 3 and part 9. Definitely, I'm glad Melanie got that thinking straight. Can Fire Smart Residential, so this is a question from Laura, can Fire Smart Residential construction part 9 be effectively balanced with low carbon emissions, i.e. fiber cement doesn't burn easily relative to wood siding? Um, hmm. Let me see if I understand that question. I mean, Melanie, do you know how to answer this at this stage? Or I would say,
The Fire Smart.
yeah.
Yeah, I think like if I understand well, it's just like when you choose your cladding, yes, embodied carbon is part of like your decision making, but like also where you're located. Maybe you're in a fire prone area that you may want to go for a cladding that is more fire resistant. It's like we're talking about embodied carbon today a lot, but there's a lot of other components when you go and choose like any material that you put in your house. There's some health, price, availability, like so much. So yeah, fire resistant cladding would be part of your decision making when you go to choose your exterior cladding, for example. So do the balance between yeah, maybe here I'm gonna use a exterior cladding that is more fireproof, maybe have more carbon emission, but then for inside, I'm gonna go and use salvage wood for my hardwood, for example. Like,
Mhm.
it's trade-off. Like this is why, like, yes, we can see it as like different material and component, and then like evaluate material for material, but seeing it as a whole. So maybe you're gonna make efforts somewhere that like gonna compensate a choice elsewhere in your building. So this is, I would see it as a whole, and yeah, keep in mind fireproof
Yeah.
for sure.
Yeah, and I mean, and this is where the buildings might start to not look so homogeneous anymore. Like maybe we'll start to see different cladding on different sides if you have certain easements and certain spacings. We've seen even a couple or one project, maybe it was in the near zero two, that they were using the cellulose insulation where they could, but because of the spacing between that building and the next on the one side, they weren't able to use a cellulose because of the fire rating restrictions. So, it's okay if you can't, it's not like a go big or go home. It's like understanding where you can intervene and use these strategies. And then sometimes the trade-offs are needing to consider, sometimes with seismic or with fireproofing or fire rating, there are other decisions, there are other factors that will influence your decisions.
Yeah, I think this is so important. Why I thought this presentation was good for our members is because it just gets us thinking about this is a conversation that needs to start to happen in our community, and we need to start thinking in terms of this. Maybe the decisions won't be made this year. I've been to a few embodied carbon presentations now, so I'm getting a better understanding as I go along. Our members might need to go to 2 or 3 more before they actually start implementing these things. But at some point, we need to start getting our mind into this is something to consider, and decisions that we make as designers can have a big impact because we're part 9 buildings, while they might be smaller, they're the majority of construction happening in the province. And like Bill said, so our decisions can have a definite environmental impact.
Thank you. And I know that as even with the Part 3 regs being proposed to council coming up, there's a lot of concern about like red tape or more policy and more this but really even the approach to that, the way those came to be and what was proposed was really based on seeing what could be done, what is like like maybe still ambitious target, but it's achievable. And the goal, the idea is that we need this policy. Like we don't want this to be something that some people can say, oh, it's a value add that we're being sustainable. And the decision is, and then that causes this kind of premium on cost for some things because it's not at a scale. Whereas when you raise the bar and you just have this as like a new baseline, this is what we're trying to do here, then it hopefully wouldn't be seen as like a barrier, but rather kind of making this the new standard, just like as we're trying to raise the standards.
There's a question from Ken I would like to answer. So Ken was asking, are product high in embodied carbon offset by how long they are expected to last, like 50 to 100 years, like concrete? What I would like to answer to that is we need to reduce our embodied carbon. We need to reduce our emission now. Like the next decade is the most important decade on are we going to be able to live on this planet in 100 years or not? So yes, you might be using a material that have a higher embodied carbon now that is promising to be there for 100 years. But that higher embodied carbon will cause more global warming now and may cause us not being there in 100 years to see that material still up and going, So this is why we need to be smart right now and try to reduce as much as we can our emission now. And it might be that like, okay, maybe you go for a material that is maybe like a shorter lifespan than what the other materials say, but it's like so much lower. And when you're gonna have to replace it in like 45 years, there will be a new option for a material that has a lot less embodied carbon than like the one that you wanted to put. So yes, if you take anything and you put it over 100 years, the emission is not that much. But what's the point if we're not going to be there to see it in 100 years? We really need to like see, like we need to have some impact right now, like because all the emission that we put right now will impact the climate for the rest of the time. So the emission that we're going to put in 40 years going to start impacting us in 40 years. But all the emission that we put right now start impacting us right now. So this is what we need to keep in mind is that like every reduction that you do right now will help us like stay. So Yeah, sometimes I get mad a little bit when people are like, "Oh yeah, but like mineral wool over 100 years is not that bad." But I'm like, this is not the point. The point is like right now, we need to like reduce our emission right now. So what can we choose now that makes more sense?
Mhm.
So yeah,
No,
that was my
no,
Good
Melanie,
comment.
I totally get that. And honestly, it's a good point because it's funny, like when we talk about climate, a lot of people think about like saving the planet, and it's like this planet has been through a lot. It does not need
will
us.
still
Like
be there.
trying to survive on this planet and make sure. And I do think again, maybe my lens is like engineering and a lot of the kind of like ethos around like when you graduate is it's about public safety. It's about like designing structures that don't fail. It's providing a service to the public. I think our understanding of climate change should be influencing our idea of public safety and like the way we design is it's for the public safety. And so sometimes that's hard because when things are not tangible or felt as much by some people, they might prioritize certain things over others. And there's some value to that, of like immediate things, but at the same time, you're right. And yes, ideally, we want to build structures that last, but at the same time, we have very little control, over how that even, excuse me, building gets used over time. We even just saw with the pandemic, all of these buildings that were commercial buildings or office buildings like were not being utilized. So there's a lot about the way we design to be adaptive. Yes, there's also value to using durable materials, because that's what allows for that like adaptability as well in disassembling and reusing those in other ways. But using building a foundation of concrete, exactly like as Melanie, as you're saying, it could have a very high impact, and we don't even get to enjoy it in 100 years' time, right?
Right.
So,
I'm
thank
just gonna, if it's all right, I'm just gonna answer. Ken had a good question that I think
you.
covers some of these things too, about designing to minimum codes for concrete and rebar because things have become industry standard. Um, and so, how does that affect the builders that are concerned about claims that might come against them? So, I will say that in Ontario, where when we do homes in Ontario, we're not allowed to spec rebar, period, unless it's in ICF walls or in concrete block walls where it's in the tables. So rebar and footings does not exist in Part 9 homes in Ontario. Rebar and walls doesn't exist in Part 9 homes in Ontario. Those have to be removed from your plans or else you can't get your BCIN certification on the drawings. So there's things we do in BC that we're allowed to do. We've been given flexibility as designers to spec rebar, but technically, according to the code, a lot of the times we spec it, it's not even in the code for us to do. It's just become common practice. But actually, if the builder was going to be held accountable, if they're building to code, which doesn't require rebar or which requires a 16-inch footing, and we decide to put a 24-inch in just because it's easier for the builder, it doesn't affect the home structurally to reduce the footing. So you have to do your research and make sure you're not going below the code standards, but the code standards are all that the builders with Part 9 are accountable to meet. And if they meet the code standards, they can't be held accountable beyond because they built to what the government has required. So good questions. And I'm not saying you should reduce your footings. You should check the tables and see if there are just things we've got into the habit of doing that are not necessary. And so good conversation though, Ken. I always like your comments. So there was a question that on ICF that I think Dylan or who was that had Cam on ICF versus wood because ICF has a greater R value. And what would happen in a situation like that?
Mhm. Melanie, I know we had
Can I
some.
have to go
Yeah,
again?
do you want to answer?
Oh, yeah, sorry.
No, no, no.
I
That's
know,
what I was
but
gonna
I
ask
can
you.
help you with that question.
Hmm? Yeah, no, go on, please. I know we had some of that in the near zero two, and there were some
Yeah.
challenges. So yeah, feel free. I know you'd have a deeper understanding of that.
Also, I'm gonna have to leave the call,
Oh,
but
right now, is that what you're saying? Oh, okay.
yeah,
But so what? Thanks so much for joining, Melanie. It's okay. I'll answer
Thanks,
you're
them.
Melanie.
welcome.
Yeah.
Okay.
So where is the
Bye,
question?
everyone.
Thank you
Um,
so
it it's
much.
just up under there was a uh, Under Ryan, just a couple under Ryan, Malcolm had a comment and then
Oh, I
Cam
see.
had a comment there.
There we go. So, if what has a less embodied carbon, okay, uh, so ICF, my understanding of like why the insulated concrete forms are high intensity is because of the XPS insulation that is typically used with it. And so, I mean, of course, concrete has its like emissions, but then the insulation part is what makes it hard to reduce the emissions there. And I saw that I'm trying to remember what it was that I was looking at. It was like the new BC design. I can't remember what the document was, but they were just like even talking about lower carbon, um, like insulation that could be used with ICF. Um, but other than that, I'm not sure why there's not more. If what has less embodied carbon. Yes, again, like there's that would be a decision that you could make. Like instead of choosing ICF, you might say, I'm going to design this in a like this foundation in a different way with materials that will be lower carbon, and then that's where you can see some reductions. Um, I don't know if that answers.
I
Uh,
would I would just add to that, just listening to your comment there and just thinking about it, that ICF wall with a 6-inch concrete core would be about 12 inches thick. If you did a 12-inch wood frame wall with staggered studs and insulation, you'd probably get equivalent or higher R value and would have less embodied carbon. So if the choice to go ICF is just for environment, like for efficiency, the same can be achieved with wood if you go with the same thickness of wall.
Thanks. Yeah. Okay, so then in the next question, and if I miss, I want to make sure I don't want to miss anything. Thanks for catching that one because I realized that was above and we missed it. Um, I recommend you back us study for building designers. Thanks, Brett. I will check that. I don't know that one myself. And then I just want to make sure I didn't miss anything. Tony, we got that. Or sorry, Ken, we got your question. Kimberly, it would be great to have practical training to review the use of sourcing guide. Okay. Kim, can you do me a favor and like copy and paste this somewhere so I can like follow up with Kimberly on this because um this is good feedback, Kim. We are looking at the way we're promoting the sourcing guide, make sure people know about it, how to use it. We're going to put together like a brochure, kind of one pager that people can also help share with others to kind of give a highlight level like overview of what it is. But maybe this is like a session that we'll hold in the new year. It's like a little bit of a training session. Maybe Tony, we can talk about how this is something we can also collaborate as like part of another session delivered through BCABD. Because that's a great suggestion. I know you're saying, I know feeling confident in using these tools is done would help. Um, yeah, absolutely. We want to make sure that's how you feel. We want this to be something that's like a no-brainer. You go to it. This is what it is. If you have feedback for us on, oh, I'm looking at this material, but it's not in your sourcing guide. If you have questions, we have people that are managing it that can be also a resource to you to help you. That's really the whole goal of CLF is to really be like convening and be industry helping each other understand these things because as Tony, like to Ken's question about codes and minimum requirements, as we're learning these things, we're also working with all of these code like CSA standards, all of these codes that are currently in place. Like how can we update this to enable like embodied carbon reduction, to enable us to reuse materials? So learning this from industry, from people who are doing it and teaching, that's what the Near Zero 2 program is super like is positioned, but it's meant to do is also just like inform us and teach us so that I could inform policy and inform code development.
I was thinking of Ken's question, is there a different type of ICF foam block? I remember years, like 10 years ago, I did a house down in, it was either Washington or Oregon, and we used I believe the brand was called Fast Wall. It's made in Oregon. And it was a compressed wood form with insulation built in as opposed to um, the rigid foam. And that was an interesting product that we used down there. I don't know if it's available in BC that, but Fast Wall, FASWALL was the brand. It might be worth looking at something like that.
Hmm. Awesome, thanks. Oh my God, Tony, do you have projects you should apply to the large part nine near 02?
Yes, yeah.
Yeah.
Well, that would be something too that I think would be maybe if we do up a follow-up session in the spring
Hmm.
or late winter, maybe we could talk a little more about how that would apply to like townhouse developments or even single family homes or subdivisions,
Hmm.
because that's where most of our developers or designers would be working within those.
Nice. Awesome. Well, Kim, we should set up a meeting with Tony and chat with them more later. Thanks, Tony. Okay, just seeing some of the last questions. Is there a different type of ICU on the market? Okay, so yeah, we see some stuff happening. Is this chat going to be saved? Is there a way for us to access the chat too later?
I believe they've got an AI companion and a chat. Yeah, I'll try to do that. Yeah. And then you can follow up with, I'll give you the contact information if you want to follow up with any of these questions on one-on-one, you can do that.
Yeah, thanks. I completely agree with you, Bill, on so many levels about like the science and that like the I share that like I share that feeling of like there's so much that we're trying to do with this, but there are so many other large contributors to emissions. I mean, there's a part of my job in like understanding about carbon and applying it to buildings, but there are people, I would say, myself included, in other ways trying to, if we're serious about reducing carbon here, and it's like something that we need to understand better. We need to build capacity for it. We need to like the comment somebody, I'm forgetting who made it, Malcolm, or was it Malcolm? No, Malcolm, you said something else I agreed with, but we were just talking about, oh, my fees are going to increase because this is more work. Like it's true. There's like some cost associated with like changing the way we do things, right? And like until we get that new baseline or that new business as usual. But there are so many things that we need funding for. We need to build the capacity for. And we need that money, and there are maybe other ways that that money is being spent that are doing things that are actively working against our climate goals. So I think that there are people occupying those spaces to try to advocate for making sure that we all have our part to play as designers, as builders, and I think doing what we can within our means is important so that the other players who are doing even more, we can hold them accountable and say, what's your excuse? Like, you need to also change things because if we have these big targets, we're doing everything we can within our means, and we need you guys to play along as well, And so I don't know if that's, if that helps kind of alleviate that, but I think that to me, like to me, I guess everybody shares a different sentiment, but we do our best with what we can and within our means for reducing emissions and really just building sustainable communities and sustainable buildings.
That's why I like the thought of just us individually analyzing what we're doing.
Mhm.
Because if you're, for example, not using rebar when it's not necessary, you're saving your builder money. So it's cheaper for them. Plus, we're making it environmentally more friendly. Or if you're reducing the size of footings to what's actually required, you're saving your builder money on concrete. Like they might have to pay a little more attention when they're putting their 8-inch form on a 16-inch footing or whatever it might be. But that's at the end of the day, it's a cost saving thing coupled with it's better for the environment.
Mhm.
So if we start with those things, because ultimately developers will develop if they can make money. If
Mhm.
developers are not making money, they will stop developing because you can invest your money in other ways. So
Mhm.
we need to look at ways to make these things work, but also benefit the bottom line for the developer. Because while they may be concerned about the environment, they're taking huge risks, especially in the last few years in the way the housing market's been. There's developers that won't make it through this last couple of years. They're risking everything they have to do developments. Are they going to add to that risk another 5 or 10% cost to achieve something that isn't going to give them 5 to 10% more security in
Mhm.
their development? So it's a balance in our industry to meet these incentives without putting the developers in jeopardy.
Totally. And I mean, this is an interesting like topic to me as well, about just business and service and an economy of like, if you want to be a thriving business, if you're a developer and you occupy space and you're good at it, but then things are changing, how does your business model change? What are new things that you like, where are you positioned to be? Because to me, developing like is something we'll always need to do. Like population is growing, we'll need to develop, but maybe the way we develop is going to shift in a way because we need to build structures. We have existing problems or challenges right now with again with like commercial buildings that are like that people are having trouble with occupancy because of new work styles of hybrid work. So are there opportunities for developers to enter a new space of finding existing structures, keeping them, but adapting them to be housing, to be mixed use, developments. So I think there's an opportunity, and I really like the last thing I want is for developers to see this as like oh, we're being forced to not like to stop. It's kind of like sometimes I have silly thoughts, but like I think about like go, no go, when you're making a decision on a project. To me, no go, it seems like a negative, but to me, you could also say that still means stay. Like no go, but stay. Like we still need you. Like don't develop in this way, but we need you to be helping us still. Like you're still relevant and you're still like an instrumental part for us to achieve this. And so that's why even within CLF, like I hope to even be connecting more with developers so that we can be learning and aligning the values and the goals and kind of seeing what we can do to get there. But again, embodied carbon is one piece. There are so many moving parts to what makes a building sustainable for people, make it livable, make it have like consider kind of wellness and well-being for people aside from just building decarbonization. So anyways, I think that it really is a team effort and everybody has a role to play and it also comes to us as the kind of consumers, as the designers who are procuring and specifying, if there are places in the world who are, that are using practices, whether they are labor law practices or whether they are practices that cause emissions that are not aligning with what we're trying to do, I would just say that means that we no longer procure those. We no longer specify those materials. And there could be bigger things that kind of domino effects to that, or that could also signal to whoever is the supplier of those things to think we need to change the way we do business too, if we want to stay relevant and to continue to be people who supply these materials. So I know that's like a bigger thing in an industry change. It's very like it's a systems change thinking, it's very disruptive thinking, but I think we need to just like do our best with what we can and signal to industry that this is what we want. And then tools, policies, codes will develop to support that transition. And it's a really transformational in terms of economic development as well. It's like we all want our economies to thrive. And that's the goal behind this. I don't think anybody's going to try to put in policies that make us fail economically. So that's why we need everybody to be a part of helping us influence or inform how policies and codes develop, so that it's not a barrier, but rather helping us kind of refine our process.
Yeah. Well, if you have 10% of the construction community making 100% shift, or you have 100% of the construction community making a 10% shift, which is going to yield the most. And that's why if you can hit the low-hanging fruit and you help that 10% shift happen, then that is something you can grow off of. But if you isolate the 90% because you're asking for 100,
Mm-hmm.
then you've isolated them. You've made it a controversial subject. So you got to look for how do we get everyone on board to what they can do by making little decisions that add up to that 10% and actually saves money for the people in the end and gives a better, as good or better product. So as an example, cladding, if cladding is something that can be reconsidered, there's a lot of cladding going on homes. Maybe that is a way to go at it. I would like to see stucco on that list because in the interior stucco is used a lot. Be interesting to see how that weighs up against I would imagine it's quite high compared to
Yeah,
other things.
that's the
So,
challenge with well, that's the thing with the carbon sourcing guide is it's like intentionally putting the low carbon materials. So if you're not
right,
seeing stucco, it's because the options in there would be better than stucco.
right.
Although maybe there's opportunity, maybe there are new stucco products that will come out that can be low carbon. So maybe these are like things that will develop over time. But yeah,
Or
uh,
metal siding, vinyl siding,
yeah,
like just as an example, like these are way up here or these are here so that you can see, okay, the wise choice would be in
yeah.
this section, right?
Yeah, and
So,
honestly, Tony, it'll be good because yeah, we should definitely be talking more because I could even just give you tools of like other websites that exist where they have like tools and ways to compare these materials like at a level. So it might not exist within the sourcing guide, but there might be other ways that you can like make those comparisons. So I'm happy to share that with you.
mhm.
Unfortunately, I have to hop off.
Okay, yeah, great. Thank you so much,
I think
Stephanie
we got
and
all the
Kim.
questions. I think there was like yeah, I hope we got them all. But yeah, thank you so much.
Great. And thanks everyone for joining in. We'll whether we'll have another presentation in December with the holiday breaks coming up, I don't know, but for sure we'll be picking up in January. So just keep an eye on the newsletters for presentations. And we'd, yeah, for sure like to carry on this conversation with ZEIC and CLF again. So thanks again, Stephanie and Kim. And I'm going to stop the recording and let everyone log out.
Oh, maybe
Oh,
before, oh, I know people are leaving. I meant to drop in and share that we have the embodied carbon exchange next week. So we have these by monthly, and they're very informal, like breakout groups of different topics, and people can just join and go into a breakout room and just have like a very casual conversation, bring questions, listen to other people ask their questions and learn. So it's a really nice way to learn more about embodied carbon as well. There's no pressure to contribute, although you're welcome and like don't be shy if you have questions. So I was like hoping to just drop that link.
I did. I shared it.
Oh, thank you. Oh, you're the
No
best
problem.
earlier. Oh,
Yeah.
you shared it earlier. Oh, you're the
yeah,
best, honestly.
yeah,
Okay, so hopefully people saw that then before. But thanks again,
great.
and yeah,
Okay.
we'll chat soon, Tony. Yeah.
Bye.
Yeah. Bye.
Bye. Thanks.